Hello everyone, welcome to this new tutorial. The topic of this tutorial is web analysis. And to start the first step, we double click on parts and we give the name as pipe fixed. Over here, we choose the shape as shell and the type as extrusion and the approximate size as 50. Press on continue. Over here, we arbitrarily draw a circle and put the dimension as 3.25 3.25. Press on OK. Now we can extrude this and put the value as 25. Press on OK. So now what we do is we copy this part and name this as pipe impacting. Press on OK. So we expand this and the features as well. Double click on shell extrude, and over here we put the value as 50, and we also edit the section sketch over here. So what we want to do is we go on to the add, and over here construction and vertical line, put it at the center, press escape, and using the trim tool we trim the left half. Press on done, but keep the value as 50. Press on OK. So this is the second part. Now we go on to create a material, and we can name this material as steel. So after doing that, put the density as 7.324 e to the power minus 4, and here we can put the Young's modulus as 30 power 6, 0.3 as a Poisson's ratio. And here we can put the yield stress as 45 e to the power 3. Press on OK. Now we create a section, and we choose the category as shell, and the name of the section can be pipe section. Press on continue, and over here we give the value of the shell thickness as 0.432 and thickness integration rule as Gauss. Press on OK. Now we can assign section assignment for both the parts. Choosing the part, pressing on done, press on OK. Similarly for the second part, select the part and press on OK. So the section has been assigned to both the parts. Now let's go on to the assembly module. Over here, double click on instances, choose both the parts and keep them as independent and auto offset from other instances. Press on OK. Let's rotate it. Over here, we go on to the instance and translate. And this is the part that we want to translate. Press on done. And the starting point is basically this point. Select this point, and this point would be the end point, which is the end point of the translation vector. Press on this, OK, and done. Next, we rotate it and choose this rotate instance option. And what we do is we choose this point. Select the instance, this one, press done, and this is the start point, and this point is the end point. Angle of rotation as 90. Press on enter, OK, and done. So next, what we want to do is we want to modify the vertical position of the impacting pipe, and this is done to eliminate the initial overclosure between the parts, between the two pipes, which you can see there's some closure over here. So let's try to eliminate this as well. This clearance, what we can do is we can use this tool, translate to, and since this is the movable instance, choose this, press on done. This is the fixed instance, press done. And now we can choose this as the starting vector, and this is the end one, and we can put the clearance as 0.432, press on preview. So basically we want it in the other direction, so let's put a minus sign over here, and now you can see there is this clearance that we wanted. Press on done, and there is a clearance now. Now in the final step of this module, we want to go on to the tools and choose a reference point. So uh, let's create a reference point at this location. So we choose this point. So this is our reference point. Now let's go on to the step module, double click on steps, and over here let's create a dynamic explicit step, and press on OK. And over here we will keep time period of 0.015 and press OK. So now we go on to the field output request. Over here expand this, and over here if we right click and press on edit. So in this dialog box we review the pre-selected defaults and change the frequency and put it as 12. Now that's all that we want to do over here, and now press on OK. Following, let's create a geometry set consisting of the reference point, and to do that we use the following steps. We go back to the assembly module and double click on sets. Over here let's create a set, and its name is reference point, and press on continue, and let's choose the reference point, press on done. So now double click on the history output request, and over here basically actually let's expand this and go on to the edit. Over here we choose the set, and in the set we choose the reference point, and the interval can be put as 100, and from the list of output variables we can actually choose, go on to the forces and the reactions one and choose RF, and that's all actually. We don't need the energies, and okay, let's press on OK. Now we have to define a general contact interaction between the two pipes and constrain the pivot end of the impacting pipe such that it behaves like a rigid body. And to do that, double click on interaction properties, and in this dialog box we accept it as the contact type and press on continue. So this edit contact property dialog box appears. Over here let's select tangential behavior, and over here penalty. So let's put the coefficient as 0.2, the friction coefficient, and press on OK. So over here now we double click on interactions. In this dialog box, uh, we keep everything as it is, no need to change anything. Press on continue, and this other dialog box, uh, what we do is we choose this, it's already chosen, so just in case if this one is chosen, just select this option and press on OK again. Okay, so we need to select this property over here, so press on OK. Now after the contact interaction, now let's make the rigid body constraint, and to do that, double click on constraints, and in the dialog box choose the rigid body, continue. So over here, if we choose the region type as pin nodes, and after doing that we press on the edit option, this one, press on done. Now next, we want to select the reference point in the viewport, and before doing that we choose this option, uh, press on this. Now the reference point has been picked as well, press on OK. Now we have to apply the boundary conditions, and to do that double click on boundary conditions over here, and in this dialog box we choose symmetry, anti-symmetry and castrate, and press on continue. So now basically we'll be applying boundary conditions to different faces, or basically different edges. And first we apply the symmetry boundary condition and we select the following edges. So this one, press on shift, this one, and this one, press on done. And in this dialog box we choose as Z symmetry, press on OK. Now we have to put on the fully constrained boundary condition. So again double click, continue, and we rotate it and such that we select this face, this edge, and after pressing on done we choose the incaster. Now for the final boundary condition, let's create another one, continue, and this point, the reference point, done, choose the pinned option. Now the boundary conditions have been created, and what we want to do is we want to put the initial conditions, and the basically the impacting pipe is given an initial angular velocity. And to do that, what we can do is firstly let's go onto the query information, and the point node option over here you want to determine the two coordinates of two endpoints. So the first point is this one, and this is the second point, press on done. So now you have the coordinates of both the points over here, and now what we can do is cross this and double click on predefined fields. Over here we choose the initial step, and choose mechanical and velocity over here, press on continue, and after doing that uh, we choose the impacting pipe and press on done. So over here we put the value of angular velocity, and before doing that we choose this to rotational only, and angular velocity is 75. So now we need the coordinates of axis point 1 and axis point 2, which we can basically copy it from here. So this is the axis point 1, and now similarly we'll select the axis point 2. So after doing that, press on OK, and let's move on to the mesh. So we expand the pipe fixed over here and mesh. So now we are in the mesh module, and we select tools and partition. In this dialog box, we choose face over here and use shortest distance between 2 points. Press on done. So basically, so these were the faces actually. Press on done. This is the start point. This is the end point. Create a partition. You can see the partition has been created. Let's zoom out. So after doing this, we go on to the mesh element type, and now in the element type, what we do is, first of all, we do it for the fixed one. Press on done. So over here, we accept the default type. Don't change anything. Press on OK. Now we need to see the edges. So first of all, we are going to see this edge. Press on done. And if you choose the by number option, we put the number as 12. And we need to seed another edge, which is this partition that we have created. Press on done. Put the value as 16. Press on OK. Now we need to change the mesh controls. So over here, if you choose this part, press on done. Over here, we need to choose the medial axis and chord mesh over here. Press on OK. Now let's mesh this part. Press on done. So this part has been meshed. Now let's mesh the other one, the impacting pipe. So we need to see the edges of this one as well, and basically for this edge it's 46. Press on OK, and over here the other edge as well. Press on done and put the value 16 over here. So after the meshing has been done, the edges have been seeded. Now simply we go on to the mesh controls, select this part, done, put on the element shape as chord and the algorithm as medial axis. Okay, and now we mesh the part. A job, and let's submit it and wait for the job to complete. So now the job has been completed, and you can see the deformation. So this is the deformation. So what we can do is basically we can actually change the color of the two pipes, and we can go on to the tools, and over here there's an option color code. So in this dialog box we can actually change the colors if we want, and so there here are the list of like color options. We can choose this color. So basically based on the two different paths, for example, you can choose two different colors if you want. You can apply and see. So see two different colors over here. So this is what you can do. Other than that, uh, you can animate as well, and basically if you go animate time history, so this is the animation, and similarly you can create uh, contour plots of Mrs. Stress and equivalent plastic strain on the deformed shape, and depending on what you want. In the previous tutorial, we have learned how to create a plot. So you can create the plot by going on to the output databases. And over here, if you see the history output, you can open the history output. For example, uh, if you want to make a graph for the reaction force, we can plot this. So this is the uh, plot for the reaction force. Similarly, you can choose other inputs, field outputs actually, and depending on what you want, you can get the graphs. So this brings us towards the end of this tutorial.